Okay, hi, linear algebra. How are you? So remember when I told you that I was going to do the arithmetic and algebra for that problem we left on the board about the plane? Well, I went back because I taught right after we met to the classroom to get what I wrote down, and it was erased. So I actually can't do that for you. If someone happens to bring in the work tomorrow, which I think you all should do, I'll do it in class, but I didn't take it down from the board. Okay, second thing, Oliver's under. Are we meeting tomorrow morning? That's our time. If we are, please let me know. And I probably should assume, Oliver, that that's a standing time, but I always like to double check. And if we are, please make sure you drive carefully and eat breakfast. All right, everyone. So what I want you to do first here is to please print out the attached. The homework here is on span. And this piece of homework here is going to cover span and also null space. So don't just do the homework tonight and then roll up the attached document and feed it to your hamster, okay? Please keep it. All right, so one thing I want to make sure that you're aware of is, just like I said to you before, different textbooks will phrase things differently, but if you understand the math, guess what? You can always think your way through it. So I just did question number 11 here on page 186. It says, show that the span of set S equals R2, or algebraically and geometrically described as otherwise. And the span for number 11 is the span of, this is set S here, okay? S here just means of some set S, and here is the set for question number 11. Vector A, vector C, and vector E. And the very first thing I noticed here is when I look at vector A and vector C and vector E, what we have here are three vectors that are dependent. Okay, this is a dependent set. Okay, so note, this set of vectors is dependent. And a couple of things that you're going to recognize. If a set of vectors is dependent, and they're all collinear, so okay, they are all dependent in the sense that they are all collinear, because you could be dependent in different ways. You understand? All right. One kind of dependence is saying like a third vector is equal to 3 times 1 plus 2 times the other, for example. A situation like that is not necessarily a situation of dependence in that all three vectors are collinear. So a set of vectors being dependent can manifest in different things, different ways. And one of the things that I want to underscore to you now that we're kind of getting closer and closer to the final exam, you'll see that I'll talk a lot more in class and then during the screencast that we have just about these ideas and tying it all up together in a really clean way. So notice with this question here, I could very quickly and easily answer the question about what the span of this set is, but I also want to make note of some important things that I just have. Namely, that these three vectors are dependent, and I also elaborated on how they are dependent, okay? So right away, if I look at this, it is clear to me that since all of these vectors are just scalar multiples of each other, they are all quote-unquote, not quote-unquote, they are all collinear. So the span of this vector is just the line y equals negative x. Okay, so these vectors, so vector A, oh gosh, how you write that mathematically is you can do this. Constant 1 times vector A plus constant 2 times vector C plus constant 3 times vector E. What this is saying is every possible linear combination of these three vectors describes the line y equals negative x in R2, right? Okay, so y equals negative x in R2, if you want to write that line parametrically, is the same thing as x equals t and y equals negative t. Okay, so to answer the question, the span of ACE is, let's see, the span of vector A, vector C, vector E is just equal to the line with equation y equals negative x. Okay, not too worried about using set notation here. I think the answers in the back of the book use set notation. I am not. All right, let's try another one just so you get a feel for how questions could be asked. Let me pick one here from homework and we'll do it. Okay. Okay, I like this one. Ready? So let's take a look at question number 20. All right. Question number 20, it says, let S be the set given in exercise 14. All right. So in exercise 14, that set is the set of vectors. It is the vector V and W. Okay. And V and W, I want to reference back, V and W are 1, 2, 0, and 0, negative 1, 1. Okay, and number 20 says, let S be the set given in exercise 14. So let S be this set of vectors V and W. For each vector given below, determine whether the vector is in the span of S. All right, so what we have to do here is we have to figure out what we need to find the span of V and W. And then once we find the span of W, we're going to ask ourselves the question and determine if, let's just do part A, okay? Determine if the vector 1, 1, 1 is in the span of V and W. Okay? All right, so the first thing I'm going to ask you is this. If you're given a set and you're asked to find the span and then determine if a vector is in the span, what are you essentially doing? What particular linear combination output of V and W do you want to get? In other words, if I want 1, 1, 1 to be in the span of VW, that means I need to account for all possible linear combinations of V and W and ask myself, within all of those linear combinations of V and W, is 1, 1, 1 one of those linear combinations? In other words, is it possible, okay, or are there C1 and C2 values such that, okay, here's what we're asking, such that C1 times vector V plus C2 times vector W would equal 1, 1, 1. Okay, is it possible to linearly combine, right, vector V and W and get 1, 1, 1? This right here is just the span of set S. So I'm going to go ahead and do this. C1 times 1, 2, 0 plus C2 times 0, negative 1, 1. Does that equal 1, 1, 1? Okay. What's interesting here is I want you to see that I'm looking at a span of two vectors in 3 space. So before we dive into the math for a second, the span of 2 3-dimensional vectors in R3, I know the span because these vectors are non-collinear. The span is going to be planar, right? And I guess the question is, does that plane include the point 1, 1, 1, right? So many different ways to ask this question. One question is there a C1 and C2 that will allow C1 times vector V plus C2 times vector W to equal 1, 1, 1? Another way to ask this question is, knowing that this left-hand side describes a plane, the question is, does the plane pass through 1, 1, 1, right? Many different ways to tackle this question. So important for us as we're closing out linear algebra to understand that there are so many different perspectives on any question, and different perspectives and speaking in different perspectives and appreciating different perspectives is the way to becoming just a smart person in general. But I digress, and you know I can digress. All right, so I'm going to just do this. C1 plus C2 times 0, which is 0, equals 1. 2C1 minus C2 will equal 1, and 0 plus C2 equals 1. Well, this one turned out to be incredibly easy. This is just number 20, part A. Well, look at this. Equation number 1 tells us that C1 needs to equal 1, and equation 2 tells us that C2 has to equal 1. Well, let's see. Certainly, it's the case that when C1 equals 1 and C2 equals 1, look what checks out, boys and girls, that 1 times 1 plus 1 times 0 does equal 1, right? And 1 times 0 plus 1 times 1 does equal 1. The question is, we got to make sure that these values of C1 and C2 also work out here. So let's check. 2 times 1 minus 1, does that equal 1? Check. Yes, it does. Very well done. So it turns out that yes. Okay, there is a combination of V and W that will yield 1, 1, 1. Or we can say this. We have shown that 1, 1, 1 is included in the span of V and W. All right. I think I'm going to ask you to do this too, actually, while we're in the spirit of proving this. Remember when I said before that I could reframe this question as describing a plane on the left-hand side, and does the plane pass through this point 1, 1, 1, correct? Okay. Can you please find the equation of the plane described by this? Okay, the span of C1 and C2 describes a plane. Please find me that plane. All right, so here's what I'm going to ask you to do. I'll write it out. Let me write it out for you. What a great question that is. Goodness, I love it. I really like it a lot. Show that the span of V and W. Oh, sorry. No. Let me rephrase. Sorry. Knowing that C1 times V plus C2 times W describes a plane, comma, part A, find the equation of that plane. Oh, I love this question. The best questions come when you're just really, oops, not a question mark. Find the equation of the plane. And 2, show that 1, 1, 1 is a point on that plane. Okay? What a great question. I love that. All right, so homework tonight is going to be to do this. Okay, and then also on the handout I gave you, you'll notice I gave you an answer sheet. I think it only gives the odds, but I gave you an answer sheet. I'd like you to do on that attachment, page 186 to 187, the following numbers. Let's do 5 and 9, and let's do 17, and let's do let's do 21E, okay, and 21F. All right, and the rest of them have to do with null space. And okay, so that's it for tonight. All right, I recommend following. You do this. Also, boys and girls, start getting your notes in order. Okay, just kind of start that very early process of getting your notes in order. And Oliver, let me know. All right, goodbye.